Hello guys, welcome back to my channel, and today we're going to continue for our math method learning, and we try to cover the 4E, the general cubic functions. Okay, so the general cubic functions is ax cubed plus bx squared plus cx plus d, and we just need to make sure a is not equal to 0, because once a equal to 0, we becomes like the quadratic, right? And it's another important thing is impossible to fully investigate cubic function without using the calculus. So the cubic function will be, again, to come up to you guys in chapter 10 once we learn the derivatives, okay, and we learn more about the math methods. And again, the shape of the cubic graph can easily change. And for now, I just want to make sure to know that the difference with if my a is greater than 0 or my a is less than 0. Okay, what's the difference? And once we look at the graph, we observe something. Okay, this one, a greater than 0, a greater than 0. Just remember a is the coefficient of the highest order, which is x cubed over here. Greater than 0, greater than 0 again, less than 0, and less than 0. And we can clearly see that for a, it's greater than 0. Our graph generally, okay, looks like this. So up, down, up, normally, okay? And for is less than 0 is down and up and down again, okay? This looks like this one. This is called the general shape of the cubic functions, okay? Just make sure if a is greater than 0, most of the time it's going to look like this one, and a is less than 0. Most of the time it looks like this one. So with this in mind, sometimes it can help for you to quick sketch the graph for the polynomials and to get some sort of ideas about what's going on over here. Okay, let's keep continuing. So is if this one is pretty important, cubic function graph has turning point on the x-axis. This means repeated factor. So look at this one here, repeated factor. So if I factorizing it, it must with something called x plus 1 square over here. Okay, and I will tell you guys about this in more details later. Okay, and let's keep going. Again, this one, the sign diagram is covered long time ago when you study, last year or say in year 11, right? Sign diagram is help us to sketch or draw the cubic functions. But before doing that, we have to convert our rules into like factorizing, right? So basically times each other. So for example, if we want to draw the Venn diagram of this function, this cubic function, we have to change in here. Okay, so 3 factor times each other together. Okay, and for again, this one is kind of using the information or the things we learned in 4D, like the factor theorem, right? And the rational root theorem or remainder theorem, but of course, in this case, we use the factor theorem. So we need to test if some numbers or some integers is the solution of our functions. So let's try plus minus 1, plus minus 2, plus minus 3, plus minus 5, something like that. Then we got this, like over here. Okay, so this part, and this part, they are just zeros. Then we can randomly plug numbers to make sure this is minus, minus or plus or negative or positive, okay? So once we sign diagram, we can easily draw the graph, like this. Of course, it's just like a quick sketch. I don't know where the turning point is. I don't know where the maximum. I don't know where the minimum. So I just like drawing, okay? Sometimes for the sec, the sign diagram is required because teacher want to see if you're understanding what's going on here. But for the most of the case in our final year exam, they will directly ask us to sketch the graph instead of doing the sign diagram, and you even don't need to show the sign diagram, okay? So for this one, the next one, they just ask you to sketch the graph. But then you have to use the calculators because these 2 points is basically for us now, it cannot really do it by your hand. But once you learn the derivative, you know it's going to be the stationary points, and you make the derivative equal 0, then you get the idea. Okay, let's keep going. And make sure you know how to use CAS to do the job properly. Okay, and this is for E. Okay, so again, for the graph sketching, and we need this one where y-axis intercept, x-axis intercept, if they have, okay, if they have, okay, and they just say prepare for the sign diagram if they ask to draw it, otherwise just ignore it, okay, and then consider the y values when x increase and consider y value when x decrease, okay, and if there is a repeated factor of power of 2, the y value have the same sign immediately to the left and the right of the corresponding x-axis intercept. Okay, so the graph gonna sort of look like this. Okay, or can be looks like this. Okay, let's keep going. 4f, polynomial of higher degrees. So once we know, like cubic, we can create by ourselves. But another most important one is like quartic. Okay, so the power of 4. Okay, and this one is the general shape. So yeah, and this one and this one is like the difference, a little bit different, but still it's power of 4. And we can see that because it has point of inflation shape, is like this one. So in here, the x minus 1 must repeat 3 times. Okay, otherwise it's going to be straight up like over here. Okay, so let's make sure this one it repeats 3 times. And for here and here and here, it means square. Okay, because it looks like the parabola at the bottom. Okay, that's the quick way to help you to define how many root or how many repeated root over there. Okay, and let's keep going. Again, we can draw the sign diagram to help you to sketch the graph. And for this part, I just want to emphasize one point. As we all know that, right? A plus or minus b can be a square plus b square plus minus 2ab, right? Makes sense. And most of the case, if I give you the x squared minus 2x plus 1, everyone can see it's x minus 1 squared, right? But for sometimes, if I give you this one, or like this example, give you this guy, is that possible you still recognize this is x squared minus 1 squared? If you can, pretty good. If you cannot, you just need to make sure you can see it clearly, okay? Once you notice with this, it's much easier to analysis, okay? Because you can directly do the factorizing, and you know that for minus 1, and you got 2 repeated roots. For plus 1, you got another 2 repeated roots, okay? So let's just look at some examples to help you a bit understanding. And again, in here, I don't like this book because we haven't really touched on stationary point yet. I know in year 11, you guys learned before, but in here, if your teacher didn't really bring it back, or you cannot really bring your memory back, the stationary points become really tricky and it's really hard to understand, okay? Technically in here, stationary point means the maximum or the minimum values in some certain regions sort of means like this one, and this one, like the turning point, okay? And look at the example over here. They just ask you to draw the sign diagram and to make sure you can get the idea of this one, okay? But this guy, again, I'm guessing you need to try plus minus 1, plus minus 2, or even plus minus 4 to test you can factorizing. So always factorizing first, then draw the diagram. No matter the sign diagram or the sketch or the function diagram, you always need to factorizing, okay, which is again emphasize the point we covered in 4D. Okay, hope this lesson or these videos help you a little bit, and next one we're going to go through the 4G and determine the rule for the graph of the polynomial. And if you like my videos, please subscribe and click the like button, and see you guys next videos. Bye bye.